Hello, this is the first of two videos on advanced class features. You might also benefit from watching the three videos by Tony Gaddis, the author of the book, in the resources folder on Blackboard. In the first video, we're going to talk about the various subjects down through 8.7 aggregation. So let's review instance fields and methods. First of all, each instance of a class, in other words, each object created from a class, has its own copy of instance variables. So we saw the rectangle class, it has length and width, and those apply, of course, to the specific type of rectangle. Instance methods are basically one method for all the instances, but they require that you have an object of the specific class in order to call them. On the other hand, you have static fields and static methods. They do not belong to a single instance of a class, so they belong to the class itself. So you use this to call a static method, you use the class name. For example, math.squareRoot. The static field is the same idea. It is owned by the class, not any specific instance. So here's an example of a simple class called countable that has a static field called instance count, and every constructor that gets called for countable increments instant count by 1. The instance count plus plus. Instance count is only initialized once for the whole class. So instance count can be used to count how many instances of this class were created. So off to the right is the use of the class. 3 objects are created, and the output, of course, is that 3 instances were created. So the countable result is 3. Here's a description graphically of the field. All 3 objects share the instance count. So static methods can be declared by placing static in the keyword, just like we saw with static fields. So when a class contains a static method, it's not necessary to create an instance of the class, an object, in order to use it. Now, you can call static methods and static fields from an object. It's rare, except for the example of counting up how many objects have been created. Here's an example of a class called metric that has a number of static methods. And miles to kilometers, kilometers to miles, that doesn't change depending on how the instance is, what the object is. It's still 1.609 miles per kilometer. And the demo off to the right shows how that works. So you call the method with the capitalized class name. So static methods are convenient. They're also called, often called utility classes. So static methods cannot communicate with instance fields. The inverse is, of course, true, that an instance method could communicate with a static field, like the count example. That's because a static method doesn't know what instance fields are created yet. All right, so we've talked a little bit about objects and their static and instance fields and methods. Let's talk about objects being passed as arguments. So this says Java passes all arguments by value, but what it really means is that an object is passed, when an object is passed, the value of the reference variable is passed, which is a memory address, where the object is stored in memory. So it's not a copy of the object that's passed, just a pointer to the object. You can imagine that a large object would be very cumbersome to create every time it was passed. So here's a visual description of it. Suppose display rectangle had an instance of rectangle called box. So it calls display rectangle, the class pass object 2 creates rectangle, creates a box, which is an instance of rectangle, and it gives it the values 12 and 5, length and width, and it passes it to the method. It doesn't pass of course, the whole rectangle object, it just passes the address. So the same memory pointer exists for both the argument box and the parameter r. So here's some code that shows how that's done. And since it passes a pointer to the same object, rectangle, the method at the very bottom called change rectangle resets the values. Instead of 12, 5, they're now 0, 0. So similarly, objects can be returned from methods. Here's an example of bank account. We want to create a new bank account inside this method getAccount and return it. We return the address of the bank account so it still knows what the balance is. All right, now the class object, capital O object, as we've said many times, is the superclass of all classes in Java. It has about a dozen methods that all work for object, but they don't necessarily work well for individual subclasses. So the toString method is one of the examples. Anytime you create an object, you ought to create a toString method. Anytime you create a class, you ought to create a toString method that goes along with it. Now you can call toString explicitly, like we show here. In this stock company, we have the ticker symbol XYZ and the price 9.62. We can call it explicitly with the toString, but interesting thing about toString, it doesn't have to be called explicitly, but anytime you pass the object to print line or print, or actually anything that prints it, you implicitly call the toString method. So all you have to do is pass XYZ company, and it will print. If it's a print method, it'll print XYZ and whatever the toString method says. It's also true that toString is called when implicitly when you concatenate. So here an object to the string. So here's a string. The stock data is colon and a line feed, and then concatenated with XYZ company, just the name of the object. So the output is the same as before. It calls the toString method, prints it out. So now in the object, it's easy enough to tell if you have not implemented the toString method, because the object version of toString method normally just has a class name and a hash of the memory address, and so we override that with a default method of our own. Here's an example of the code we've been talking about. The toString method down to the lower left says what when the string is called, how it will be, and then to the upper right, the demo shows how we print XYZ company implicitly, and it calls toString. Now there's also another commonly used method that has its default in the object class, and that's the equals method. Now in Java, I've said this many times before, but when you use the equals operator, it's used in two different ways. When it's used to compare primitive variables which are pointing to primitives, it looks at the primitive and decides if that, and returns true if those two primitives are equal, false if they're not. When it's used with reference variables, in other words, variables that hold memory addresses, it compares the actual memory address of the object. So the contents of the objects are not compared. That's what the equals method is for. So in general, the equals method means that two objects are the same if the programmer codes it up to be the same. So it's up to the programmer to decide what the equals method should declare. So again, the default operation of the equals method is just to compare memory addresses, just like the equals operator. So here's the stock class again with an equals method. If we try the following, where we just use equals, that's a mistake. It'll just say no, they're not the same, because it's a different memory address. Obviously the stock object is created twice, even though it looks like the same data. So here's one example of how you could write an equals method for stock objects that actually does show if the equals method, if those two stock objects are the same. And again, notice that the programmer has decided that two stock objects are the same if their symbol is the same and their share price is the same. It doesn't have to be that way, but that's the way the programmer decided. So you call equals, the first object calls the method equals and takes as an argument the second object. And if that returns true, then the objects are the same. Now in this case, our two stock objects can be said to be equal because they both have the same data, and that's how we constructed the equals method. All right, copying objects. There are two ways to copy an object. You can't use a simple assignment operator to copy an object, because the assignment operator just points the new variable to the same object. So there are basically a shallow copy and a deep copy. We say the deep copy is correct because a shallow copy can give the client programmer access to the internal objects. And that's not usually desirable. So a copy constructor is one that is just like any other constructor, but it takes an object of the same type and sets all the fields to the same value. So here's an example of a copy constructor for a stock object. It just sets the two fields, symbol and share price, to be the same as whatever the other object had. And that, being a constructor, returns an object which has the same data, so it would pass the equals method, but it is a different object. So let's talk about aggregation. When we have an instance of one class referred to in another class, we call it object aggregation. And that, in artificial intelligence terms, creates a has-a relationship between the objects. In other words, X has a Y. The most obvious example is a car has wheels. A car has a steering wheel. A car has four wheels. If you can say the has-a sentence and it makes sense, then it is an aggregation relationship. Here's an example of an instructor and a course. Well, here's the instructor, and the instructor should have an office number, a last name, and a first name, and those are all strings. And now here's a textbook class with its code, and it has a title and an author and a publisher. All three of those fields are strings. And here's a course. So the course takes an instructor and a textbook and a string course name, and that shows, so instructor and textbook are aggregated into course, because course has an instructor, and course has a textbook. Here's an example of running the demo. And the diamond shows the aggregation in UML, Unified Modeling Language. So we have built up, we see to the lower left an instructor class and to the lower right a textbook class. They are aggregated into course. So course has an instructor, has a textbook. Okay, part 2 of the slides are coming up. As I mentioned before, this is kind of a potpourri of slides.